Guess my video got cut off there, so I'm going to try to redo that a little bit at the end there. So, as we were saying, the goal here is to be able to take an X and a Y and turn that into an R and a theta, okay? So we're going from rectangular coordinates to polar. So if we are given an X and a Y, if we look back at our toolbox here, basically that we can use, if we are given an X and a Y and we want to find an R, we can just use, the X squared plus Y squared equals R squared, or the R will just equal the square root of 3 squared plus the negative square root of 3 squared. Okay, so 3 squared is 9, square root of 3 squared negative is still positive 3, which is going to be 12. So R is going to equal the square root of 12, which will simplify to 2 root 3. Now, keep in mind, in polar coordinates, like we just said, you can have a positive or a negative here. So that's going to be important to take care of or keep track of, because it depends on what quadrant we're really trying to get to. How do we know what quadrant we want to get to? Well, if you just think that point right there, that point is right 3 and down square root of 3. So we're definitely going to the fourth quadrant here. We have to make sure we end up in the fourth quadrant. So there actually is going to be 4 different answers to this. If we use positive 2 root 3 as our R, well, then we have to make sure we get an angle that gets us to the fourth quadrant, okay? So the way we get our theta, again, if we go back to our toolbox here, we can just take the inverse tangent of y over x, and that will give us our theta. So we can just say theta will equal the inverse tangent of my y, which is negative root 3, over my x, which is 3. Again, from our table, we know tangent is root 3 over 3 at a 30-degree angle, right? Again, it's negative. We know there's tangent's negative in the second and the fourth quadrant, but we already knew we want to be in the fourth quadrant. So, a 30-degree angle in the fourth quadrant would be 330. So this would be I'll call it the positive answer here. Another version of that same angle would be 2 root 3, and then another way to get a 30 in the fourth would be negative 30 degrees. So we could have something like that. That's a second answer. Yes, we could have went negative 2 root 3, but if we wanted negative 2 root 3, well, that would mean we'd have to go backwards to that point. So we would have to have an angle in the second quadrant. So a 30 in the second would be something like 150. Or the fourth answer would be negative 2 root 3, and it'd be negative 210, okay? So those are 4 different versions, or 4 different answers of the same thing. This would be the best answer because it's both positive, but any of those answers would also suffice, okay? Let's try another one here, okay? Negative 2, negative 2. Again, the goal, take an x and a y, turn that into an r and a theta, okay? Again, the way we find our r, square root of x squared plus y squared. 2 squared is 4, 4. So we get the square root of 8, which is going to simplify to 2 root 2. Again, it could be positive or negative. So there's our r value. Okay, and the way we find our theta is just the inverse tangent of our y over our x, okay, and that's just 1, and we know tangent is 1 at a 45. Technically, it's positive. It's positive in 2 quadrants, first or third. What quadrant do we want to get to? Well, if you just think about that point, negative 2 would be down here, right? So we have to be in the third quadrant. So a 45 in the third would be 225, okay? So 225, this would be our best answer right there, okay? And again, we could find the 3 other versions of that same angle, okay? So that's how you do points. But we can also do equations, like full equations in the different form. This is an equation. We know it's an equation of a line. We could put it in slope-intercept form and find the slope, find the y-intercept, do all that stuff. But we can also graph it in polar form, okay? And the way we would want to do that is basically turn all these x's and y's into r's and thetas. We know, using our toolbox, that x is just equal to r cosine. So I could substitute that x for r cosine. And we can also do the same thing with the y. We know y is equal to r sine, so it's just a substitution problem there. Now, technically speaking, we are already into polar form. But just like in rectangular form, where we have special forms, we have a standard form, we have slope-intercept form. In polar form, what we try to do is we try to get the r by itself. We like equations to say r equals. Similar like in rectangular, we always try to solve for y equals. Those are kind of the best way to handle things. So in this case, the easiest way to do that would actually be to factor out an r, which you would just get 5 cosine plus 2 sine, and then we can just divide. So in this case, r would equal 1 divided by 5 cosine theta plus 2 sine theta. Okay, so this equation and this equation up here actually are the same equation, just in the different forms. And again, the idea here is there are certain things. Lines are easier to deal with in rectangular form. I'm not going to try to convince you otherwise. But we can deal with them in polar form as well. But some things are actually easier to deal with in polar form, and that's why we have it, okay? So again, let's try another one. This one, we know it's a circle. It's x squared plus y squared equals 36. We actually already know this is a circle with a radius of 6. But if we made some substitutions, we know what x squared plus y squared is. This is r squared. So we can make that substitution. Well, and just solve for r by taking the square root. This equation, a whole lot easier equation, is actually the exact same thing as that, just in different forms. So some things do get a whole lot easier, okay? Let's try going the other way. Let's try going from polar into rectangular. Again, think about your toolbox. The goal here is to get rid of the r's and the thetas and turn them into x's and y's. We know r is equal to the square root of x squared plus y squared. So I can make that substitution right now. R is equal to square root of x squared plus y squared equals 10. And we know sine is y over r. Okay. Now, we're not totally into polar form now because we still have that r. So we got to get rid of that r there. And we can make the same substitution we made there. So that's the same thing as x squared plus y squared equals 10y, and we can replace that r with the square root of x squared plus y squared. And again, we can simplify that just a little bit, get that out of there, butterfly that. This times this would just be the square roots would cancel. X squared plus y squared equals 10y. We could go further. I'm not going to go any farther than that. We could get the 10y over there, complete the square like we did in the conic sections chapter, do all that fun stuff. But certain things, again, are just going to be easier, nice and prettier in polar form. Some things do get a little bit uglier when we deal it in rectangular. Okay, let's try some a little bit harder ones here. Let's try this one. Again, we can just use our toolbox. Goal is simple: get rid of x's and y's and replace them with r's and theta. In this case, I see the x squared and the y squared, and I could actually simplify that just a little bit by pulling that 4 out of there. And if I pull that 4 out of there before I do any substitutions, well, then I can just substitute right away, because x squared plus y squared would be r squared. And then I can just get rid of that y by y is r sine. And then I just got to simplify. Well, an r actually will cancel if I divide both sides by r, leaving me with 4r negative 3 sine. And then I can just divide by 4 to get the r by itself. So I'd get negative 3/4 sine of theta. Okay, so that would actually be the same thing as that up there. Okay. Let's try one that looks a little bit uglier in polar form. Well, in this case, again, I don't like the fraction here, and I could make a substitution. I could make a substitution here, but I think it'd be easier if I butterflied that first and got 2r plus r sine is equal to 1. Okay? Now, that r sine, if I look at my toolbox, r sine, that's just equal to y. So I can just replace that right now with y. And now I just got this r here, okay? So that would be the square root of x squared plus y squared. And then technically I'm into rectangular form, but I would want to simplify that a little bit. Easiest way would be first to get rid of that y. So throw that over there, 1 minus y. Then I can square both sides, right? And if I square both sides, this would just become 4 times x squared plus y squared. 1 minus y, if you want to do it out separately, 1 minus y, 1 minus y, you'd end up with 1. You'd have a negative y, you'd have another negative y, so you have negative 2y plus y squared. So you'd have 1 minus 2y plus y squared. Okay? And then again, we could simplify that just a little bit further. Yes, I would distribute this, getting 4x squared plus 4y squared. I would move everything to the left side. So if I had 4y squared, I bring this y squared over. I'm going to end up with 3y squareds. Bring that 2y over. Bring that 1 over just to get everything on one side. That's probably a good spot to leave it there. But you get the general idea. Some things are, they get a little bit ugly in rectangular form, where in polar form, just might be a whole lot easier to handle. Okay? Try a few problems. Let me know how it goes. And other than that, I will catch you guys later.